Hello grade 11, welcome again with you Mrs. Minna Raouf, your chemistry teacher. Today we will answer together our revision sheet and we will start by chapter 18 organic chemistry. It shows which homologous series contain carbon-carbon double bond. The alkenes which contain the carbon-carbon double bond. Number 2, which series contain carbon-carbon single bond. The alkane which contain the single bond. COOH is the function group for carboxylic acid. Number 4, OH is the function group for alcohol. We can find the OH at alcohol. How many carbon atoms are in methane? In methane mean one carbon atom, so it will be 1. It will be 1. Number 6, hydrocarbon are compounds that contain hydrocarbons, so it will contain carbon and hydrogen. Number 7, alkane with formula C3H8 is called C3 mean prop, so it will be propane. Propane is C3H8. Oil is liquid at room temperature as it contains unsaturated alkene, because unsaturated alkenes is liquid are liquid at room temperature. Number 9, alkenes can be converted to alkane by adding hydrogen to carbon atom by a process called hydrogenation. So this is process called hydrogenation process. Number 10, the following diagram represent 1, this is 1, 2, 3, 4, this is butane. And because we have here the double bond butene, and this will be trans 2 butenes because the 2 methyl group in different direction. Number 11, alkanes are alkanes. Alkanes mean single bond, so it will be saturated hydrocarbon. Alkenes have the formula, alkenes with the double bond have formula CnH2n. But CnH2n plus 2, this is for alkane. And CnH2n minus 2, this is for alkyne. The process that converts large alkane to small alkanes is called cracking. Identify C2H5OH. So OH, this will be alcohol. And C2, this mean 2 carbon, this is mean eth, so it will be ethanol. So this will be ethanol. Number 15, the following diagram represents, we have here 1 oxygen atom between 2 hydrocarbon, so this will be ether, and here we have 2 carbon from this side and 2 carbon from this side, so it will be diethyl ether. Give the IUPAC name of the following. The first one we have here 1, 2, 3, 4 carbon, so this will be bute, and double bonds, so the end will be ene, so butene, and we write here 2 butene because the double bond will be at carbon number 2. The second one here we have here 2 carbon mean eth, and ethyne end by yne because we have here triple bond, and 1 ethyl because the triple bond at carbon number 1. After that we have here how many carbon. First begin to count the carbon. 1, 2, 3, 4, 5. We have here 5 carbon. 5 it will be bent, and benzene with ene because we have double bond. Where is the position of double bond? The double bond at carbon number 2. Here is from here 1, 2. So at carbon number 2, we make the numbering from the side of the double bond. So it will be 2 benzene. And we have here 2 side chain, methyl group and methyl group at carbon number 2 at carbon number 4, 2,4 dimethyl. This one we have here 3 carbon, 1, 2, 3 carbon. We have here double bond, so it will be propene, and 1 propene because the double bond at carbon number 1. After that, we have here all the bond is signal bond, so we will make count 1, 2, 3, 4, 5, 6, so it will be hexane, and the side chain at carbon number 2 and carbon number 4, so 1, 3, 4 trimethyl, so 2, 4 trimethyl hexane. After that, we have here all single bond, so we'll make the count for the longest chain. This will be the longest chain. We have here 5 carbons, so it will be pentane, and the side chain methyl and ethyl. We will put the ethyl first because the alphabetic E come before M, so we will write first 3 ethyl 2 methyl. So 3 ethyl 2 methyl pentane. The last one, this is ring, consists of 6 carbon with 3 double bond, so this will be benzene ring. After that, the process of adding hydrogen to alkene is the following reaction. This is the reaction. This is called hydrogenation process. Hydrogenation process, where we add hydrogen to alkene to convert it to alkane. Mention the name of the following isomers. We have here 2 butene isomers. This is cis-butene because the 2 methyl group here in the same side, and this is trans-2-butene because is in the here in the opposite side. After that, fill in the following. Hydrocarbon are organic compound containing only carbon and hydrogen. Number 2, the type of hydrocarbon, saturated and unsaturated hydrocarbon. Number 3, carbon atom can form single, double or triple bond. The general formula of alkane. The alkane have formula CnH2n plus 2. Alkanes are solid at room temperature. The alkane with formula C2H6, C2, so this will be eth. So, and this is alkane, so it will be ethane. And C5H12, this will be pentane. The formula C4H10 is called butane. Why we write butane? Because here we have 4 carbon, it will be but, and CnH2n plus 2, 4 times 2 equal 8, and the plus 2 it will be 10, so it will be all single bond, so we will write end by ane. And formula of propane, so it will be C3H8. Number 8, the hydrogen with double bond are called alkenes. The general formula for alkenes, CnH2n. Number 10, when molecules differ only in the position of the double bonds, this is called positional isomers. And we should know that the alkenes are liquid at room temperature. And number 12, oil is liquid at room temperature because oil is alkenes, while butter is solid at room temperature because butter is alkane. Number 13, who can convert it to alkane by adding hydrogen to carbon atom? This is hydrogenation process, so the answer will be alkenes. And this is the definition number 14, the definition of hydrogenation process. Again, the process of converting of unsaturated alkenes to saturated alkanes by adding hydrogen. Number 15, hydrocarbons that contain carbon-carbon triple bond is called alkynes. Compounds that contain 6 carbon ring with double bond are called benzene ring. Number 17, what's the source of hydrocarbons? We can find the hydrocarbons from petroleum, natural gas and coal. Number 18, what's the ways of producing the hydrocarbons? Fractional distillation, reforming and cracking. And cracking is a process that converts large alkane to small alkanes and alkenes. After that, number 20, the process that separates petroleum into many hydrocarbons are called fractional distillation. So fractional distillation, where we separate petroleum into many hydrocarbons. After that, chapter 20, chemical reaction and energy. The reactions that give off heat called exothermic reaction. Delta H of the endothermic will be positive. The decomposition of water is endothermic reaction. 1 food calorie is equal to 4.184 kilojoule. Number 5. Burning of wood is an example of exothermic reaction. Number 6 is used to measure the heat generated in the chemical reaction. What we use to measure the heat generated? Calorimeter. In plant, what absorb light and they change it to chemical energy? Chlorophyll. After that, problems. The compound B5H9 was once proposed as a rocket fuel because it has high heat of combustion. In a combustion experiment, a scientist observed that 1 gram of this substance burned in excess oxygen in a calorimeter rises the temperature of 800 grams of water from 24 degree to 44.3 degree. How much heat is generated in the reaction? First, we will use our equation for determine the heat generated. QW equal M delta T CW, and we must know that the QW is the amount of heat of the water, M is the mass of water, delta T is the change in the temperature, and CW is the specific heat for water. Delta T equal delta final minus delta initial, so it will be 44.3 minus 24, so it will be 20.3 degree. So we will replace now the symbol in the equation by the numbers that given in the problem. So we have here how many gram of water? 800 gram, and we should use here in this equation the mass of water by gram. So 800 times the difference of temperature, 20.3 times the specific heat of water, 4.184. So it will be 77,692.1 joule, and we will divide it by 1000 to be in kilojoules, so this will be 77.69 kilojoule. This is the amount of heat by water, Q water. But we know that heat of reaction is equal negative heat of water, so it will be negative 77.96 kilojoule. Number 2, an organic fuel is burned in a calorimeter. This reaction relies about 194 kilojoule of heat. If the initial temperature of water was 21 and the final was 51.9, how much water was in the calorimeter? Here is the opposite from the last one. He wants to measure now the mass of water. So in same equation, we will replace the number from the our problem, and we will calculate first the delta T. It will be 30.9, and by replacing our given number in this equation, we have here the amount of heat for water. It will be 194 kilojoule, and we will make it by joule by multiply it by 10 power 3 or 1000. So this will be the heat for water equal M, this is the mass that we want to calculate, times 30.9, this is the difference in the temperature, and 4.184, this is the specific heat of water. So the mass will equal 1500.5 gram. We will divide it by 1000, it will be 1.5 kilogram. This is the mass of water in the calorimeter. After that, Fill the following. Number 1, burning wood is an example of exothermic reaction. Number 2, exothermic mean release heat energy. And exothermic reaction give off heat because the products are at lower energy level at the reactant. Number 4, the endothermic mean absorb heat energy, and in the endothermic reaction the heat of the product are higher energy level than the reactant. And we should know that the formation of water is example for exothermic reaction. And again, in exothermic reaction more energy is realized in the forming of the bond in the product. Number 8, the decomposition of water is endothermic. So the formation is exothermic, but the decomposition is endothermic reaction, where the reaction absorb heat. Number 9, the difference between the product and the reactant in a chemical exchange is called delta H. Number 10, for an exothermic reaction, delta H in exothermic will be negative, but delta H in endothermic will be positive. And delta H equal H of product, the heat of product, minus heat of reactant. Catalytic converter is a car exhaust reduces air pollution by reducing the emission that leave a car exhaust system. Number 13, the development of better catalyst has lower the energy required for chemical process. So the catalyst lowers the energy required for the chemical process. Number 14, the process of converting sunlight energy to chemical energy by using cell is called photosynthesis process. Number 16, photosynthesis is divided into two basic series of reactions. This is called light reactions and Calvin cycle. After that, mention the following diagram. We have here the figure number 1 and figure number 2. He wants from us to tell if the graph in figure number 1 show, this graph will show exothermic reaction because the reactant at higher energy level than the product, while graph number 2 show endothermic reaction. And question number 3, formation of water is an example for exothermic, while the decomposition of water is an example for endothermic reaction. Chapter 21, the nuclear chemistry. It shows the French scientist who discovers the radiation from the uranium called Becquerel. Rays that has high energy form of electromagnetic radiation without mass or charge, so it will be gamma rays. Rays has mass of 1 electron, this will be beta. Number 4, particles are of 1 helium nuclei, this will be alpha. Number 5 is the time required for half the atom of a radioactive nuclide to decay, called half-life. Fill in the space are the 3 types of radiation, alpha, beta, and gamma. The scientist who is studying the fluorescent uranium compound called Becquerel. And number 3, Becquerel discovered that uranium spontaneously gives off radiation. Number 4, radioactivity is the spontaneous emission of radiation by an unstable atom nucleus. What are the isotopes of carbons? Carbon 12, carbon 13, carbon 14. The release of radiation by radioactive isotopes, for short, is called decay. Alpha particles are helium nuclei, consist of 2 proton and 2 neutron, and it can be represented by helium 42 or alpha symbol. And which particle has high energy electron is called beta, with 1 negative charge, and is written as electron 0 negative 1. Number 10, gamma is a high energy form of electromagnetic radiation without mass or charge. So gamma doesn't have mass or charge. who can cause a great harm to living cells? Gamma rays. And also gamma rays doesn't affect the mass number or the atomic number of the nuclei. What is the process of combining two or more nuclei to form a larger nucleus? This is called nuclear fusion. And nuclear fission is the splitting of the atomic nuclei into two or more small fragments accompanied by a large release of energy. What's the name of the device? Sound an alarm in the presence of smoke particles. This is called a smoke detector. Here, label the figure. We have here number 1, 2, 3. Number 1 will be gamma, the more penetrating, gamma rays. Number 2, the beta rays. Number 3 will be alpha rays. Label figure number 1 and number 2. Here is the combining of two nuclei together, so will be nuclear fusion. But the splitting of the nuclei will be nuclear fission. Complete the following nuclear equation. We have here carbon 14,6 will be nitrogen 14,7. No change here in the mass number, but the change in the atomic number, it will rise by 1, so the radiation here will be beta. But here we have decrease in the mass number by 4, and here in the atomic number by 2, so this will be alpha radiation. Here the mass number will be the same, so it will be beta radiation. But here the mass number and the atomic number, the two affected, this is by 4 and this is by 2, so it will be alpha radiation. Iodine and xenon, the effect here adds only the atomic number rise by 1, so it will be beta radiation. Now we have finished our revision sheet. I hope you understood the sheet well, and please check LMS and print your sheet and try to solve it alone. Thank you for listening. Bye bye.